Welcome back, TechBusters. After mastering for loops, it's time to dive into the second part of our looping saga in Python, while loops. These loops are all about keeping the action going while a certain condition holds true. Think of while loops as the endurance runners of Python. They keep moving as long as the path is clear. Let's delve into the essentials of while loops in Python. Unlike for loops, which run for a predetermined number of times, while loops are all about conditions. They keep running while a certain condition is true and stop when it's not. Imagine a car that keeps driving as long as the fuel lasts. That's what a while loop does with its condition. A while loop typically starts with the keyword while, followed by a condition. The code block under it runs repeatedly as long as the condition remains true. Here's the basic anatomy of a while loop in Python. The condition is evaluated before each iteration. If it's true, the loop continues. If false, the loop exits, and the program moves on. It's the loop's way of asking, should I keep going? Let's look at a simple example. Say we want to count from 1 to 5. We can use a while loop to do this efficiently. In this snippet, our condition is count = 5. The loop starts with count at 1 and keeps printing and incrementing count by 1. Once count reaches 6, the condition becomes false, and the loop stops. It's a straightforward yet powerful way to handle repetitive tasks based on a condition. With the basics of while loops under our belt, let's explore the heart of these loops, condition-based looping. In this approach, the loop's continuation is determined by a specific condition, making it a dynamic and flexible tool for many programming scenarios. The condition in a while loop is like the fuel gauge in a car. As long as there's fuel, or as long as the condition is true, the loop keeps running. This condition is evaluated before each iteration, and it dictates whether the loop should continue or terminate. Crafting an effective condition is crucial for a while loop. It's not just about checking a variable. It's about ensuring that this variable or condition changes over time. Otherwise, you might get stuck in an infinite loop, like a broken record playing the same part over and over. In this example, we have a counter that starts at 0. The while loop runs as long as the counter is less than 10. With each iteration, we increment the counter, ensuring that eventually the condition counter 10 becomes false, and the loop exits. Condition-based looping is incredibly useful for tasks where you don't know in advance how many times you need to loop. For instance, reading data from a file until the end, or waiting for user input in an interactive application. Here, the loop continues to prompt for and process user input until the user types exit. It's an effective way to handle continuous user interactions. As we delve deeper into the world of while loops, let's explore two essential tools that give you more control over your loops: the break and continue statements. These powerful keywords allow you to manage the flow of your loops with precision, adapting them to various scenarios. First, let's talk about break. This is your loop's emergency exit. When Python encounters a break statement, it immediately exits the loop, no matter where it is in its cycle. It's like hitting the stop button on a player when you've heard enough. In this snippet, we set up an infinite loop with while true. Normally, this loop would run forever, but with our break statement, we tell Python to stop once the counter reaches 5. It's an effective way to terminate a loop when a specific condition is met. Next, we have continue. Think of it as your loop's skip track feature. When Python hits a continue statement, it immediately jumps to the next iteration, skipping the rest of the code in the loop for the current cycle. Here, our loop counts from 1 to 10. But with the continue statement, it skips over the even numbers. Whenever counter is even, continue jumps back to the start of the loop, and we only print the odd numbers. It's perfect for when you want to bypass certain iterations. While break and continue enhance the flexibility of your loops, they require strategic use. Overusing them can make your loops complex and harder to follow. The key is to use them judiciously, ensuring your loops remain readable and maintainable. Having explored break and continue, let's delve into another intriguing aspect of while loops: nested. While loops. This concept involves placing one while loop inside another, creating layers of looping. It's like embedding a wheel within a wheel, each spinning at its own pace, yet working together in harmony. Let's illustrate this with a simple example. Imagine you're tasked with printing coordinates in a 2x2 grid. You could use two nested while loops, one for the rows and another for the columns. In this snippet, the outer loop iterates over the rows, and for each row, the inner loop iterates over the columns. As a result, we get the coordinates 0, 0, 0, 1, 1, 0, and 1, 1 printed out, each pair representing a point in our 2x2 grid. And there we have it, the essentials of while loops in Python. These loops are about persistence and flexibility, making them indispensable in your Python toolkit. With careful control and a clear exit strategy, while loops can power a wide range of repetitive tasks and long-running processes. So go ahead, give them a try, and watch your Python skills loop their way to new heights. Join us next time for more Python adventures with TechBuster, where coding meets fun and creativity.